when we tell about potential, uh, we will see that mm, it tells about the direction of flow of the charge. We know that when anything that only at higher potentials, charge will be flow from higher to lower. Suppose we have a charge here plus q charge here at point O, and we brought any test charge q naught from infinity to at point P, suppose point P, at a distance r from the test charge, from the charge. Then we have to do a work, and this work will be stored as a potential at that point. So potential at any point at point P, that will be the amount of work done in bringing a unit charge from infinity to a point, infinity to a distance r line, work done upon a test charge. That will be the potential. We will see how we can also define potential in a different way. We will see how it is related. Suppose in order to move a test charge, we have to do a work, and that work will be stored in the form of potential energy. Suppose at point P, what will be the electrostatic force? Suppose the electrostatic force acting between them, let, you can say that let electrostatic force acting on test charge, that is F, and let be applied force F external equal to F electrostatic force then object will be moves, charge will move without any acceleration, as known as net force, zero. Infinity to a point in an electric, you can say that without acceleration is gone. So amount of work done that will be, suppose P say we move say distance q at a distance between them is dr, then we have to do a small amount of work dw, that will be the force, applied force into, that will be dr, and that one is equal to that. So total work done, that in bringing charge from infinity to a point that will be F external, that is equal to electrostatic force dr, that will be the work done. So potential, about potential will be amount of work done upon test charge, that one is equal to minus infinity to r f upon q naught, that will be e naught dr. So we can also define, we can also define as electric potential is line integral of electric field. Okay. Now, what potentials? What will be the potential? Potential due to point charge. Okay. Work done. So same situation. We have infinity. We have moved the charge from infinity to point P at a distance r. So work done, as you know, work done will be equal to negative sign infinity to r f dot dr. Same direction, so we can also write this one is infinity to r f fr f dr, that one is equal to infinity to r f 1 upon 4 pi epsilon naught q1, q is here, q naught upon r square dr. Force, work done, force into displacement. Okay, and that one is equal to, you can take out common, minus 1 upon 4 pi epsilon naught q naught, one of this one is equal to r minus 2 dr, that will be minus q naught upon 4 pi epsilon naught, this integration r minus 2 plus 1 by 2 plus 1 to r. Okay, that one is equal to minus q naught upon 4 pi epsilon naught, that one is equal to minus plus हो जाएगा 1 upon r, that will be 1 upon r upper limit 1 upon r minus 1 upon infinity is equal to q naught upon 4 pi epsilon naught r. Therefore, potential at point P, that one is equal to q naught, that one is equal to 1 upon 4 pi epsilon naught q upon r. So this will be the potential at point 1 upon 4 pi epsilon naught q upon r. This will be the potential at point P. You can also find out what will be the unit of potential. Unit is potential, the unit will be volt. Dimension of potential. You take LCM. r minus a, r plus a, r plus a minus r plus a. That one is cancelled out. So 2a, that will be now bp is equal to 2a cube, which means p हो गया 1/4 pi epsilon naught p upon, that means r square minus a square. A is small, so a square is very less than r square. A is very, simply say a is very less than r, so it can be neglected. So square of this one is further smaller, that can be. So potential at P is equal to 1/4 pi epsilon naught P upon r square. ऐसे ही second one, ब्रॉड साइड ऑन पोजीशन निकालना हो. सेकेंड, इलेक्ट्रिक पोटेंशियल on perpendicular bisector of dipole. Again, two charge. This is one is a dipole, minus q plus q separated by a small distance 2a. We have taken perpendicular bisector any point p. Suppose its distance is r, so that will be obviously perpendicular bisector, so that will be also a potential at point p due to charge at b. That one is equal to 1/4 pi epsilon naught q upon r. Potential at point p due to charge at a, that is 1/4 pi epsilon naught minus q upon r. Therefore potential at point b due to dipole, that one is sum of this one, and that becomes 0. So electric potential on perpendicular bisector of dipole on plane, cos you can say that plane perpendicular bisector of dipole is 0, is always 0. Now third case, we are going to find out electric potential at any arbitrary point, any point due to dipole. Again, same situations are there. Suppose this is dipole, a minus q plus q separated by distance 2a. Suppose this is midpoint of dipole. Suppose p is any point which is at a distance r, making some angles in angle theta with the dipoles. Here position, point p position represented by polar coordinates r and theta. Okay. So we join this one, okay, so we join this one. Now we will draw a perpendicular from point B. This distance we have taken r, don't confuse it. Perpendicular, we have drawn perpendicular. Yeah, this will be a, this will be a. Now we produce this one, and we have drawn a perpendicular from here. This is a perpendicular from here, m, and this one m, which intersect. Now these are perpendiculars in triangle ONB. This angle is theta, cos theta, base ON upon hypotenuse OV, ON to OB is equal to A cos theta. Similarly, in triangle OM, AMO, AMO cos theta, that one is equal to this one angle theta, cos theta, that is AM upon OA, or AM is equal to A cos theta. Now potential at point P due to charge at B, that is 1 upon 4 pi epsilon naught Q upon R, that is Q upon R is PB, that is 1 upon 4 pi epsilon naught Q upon PB is equal to PN, that one is equal to 1 upon 4 pi epsilon naught Q PN, PO minus ON, that is R minus A cos theta. Similarly, potential at P due to charge A, 1 upon 4 pi epsilon naught Q upon PM, PA, that is equal to 1 upon 4 pi epsilon naught Q upon PA. PA means PM, that one is equal to 1 upon 4 pi epsilon naught Q upon R plus A cos theta. Therefore, resultant potential at P, that will be the algebraic sum of this one. Point A, discharge is negative, okay. So 1 upon 4 pi epsilon naught, we can also take charge Q common, so that will be 1 minus R minus A cos theta minus 1 upon R plus A cos theta. Simplify this one, Q upon 4 pi epsilon naught, and this one A plus B minus B, R square minus A square cos square theta, R plus A cos theta minus R plus A cos theta. This one cancel out. AQ, that will be P. So 1 upon 4 pi epsilon naught P cos theta upon R square. A very small size square of this one, further small can be neglected. That can be neglected. Therefore, potential at BP is equal to 1.45 epsilon naught P cos theta upon R square. So this is a general expression for potential. From this relation, you can find out potential at point at any point, either in axial position, broad position, or anywhere. This is potentials. Similarly, after that we have to find out potential, electric potential energy, equipotential surface, then we see out what will be the work done in rotating a dipoles in uniform electric field, what are the relations between electric field and potentials. As you will see that electric field, that is the negative of potential gradient, we will see that. So that will be all these things we will see in our next video lessons. Okay, thank you.